Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. We're continuing our discussion on radicals, and that brings us to complex numbers. In the last video, we looked at imaginary numbers, and I gave an overview of those. And in this video, we're going to apply that in what are known as complex numbers. Everything that we're going to go over in this video, you can find in my book, Algebra in Words 2, in which I go over imaginary numbers and complex numbers starting around page 70. And the link to that is in the description box below. Alright, so first of all, what is a complex number? A complex number is a very easy concept to understand. Let's just focus on this. 1 plus 8i. And a complex number means it's basically a binomial, one part of which is a real number and one part of which is an imaginary number. You can tell which is the real and the imaginary part because the real part is just a number, or it might be a variable like x, and the imaginary part has I tacked onto it somewhere. Also, the way that we write complex numbers is the real part is written first and the imaginary part is written second. Now, the way that you should treat and understand complex numbers really is to treat any term with I just like it's a term with a variable of any letter, like x. The only difference is how you apply powers of I, such as I squared, normally at the end of a problem. And I'll show you that when we get to it. But regardless, you're going to apply complex numbers and any terms with I. You can do normal operations with them, such as addition or subtraction, combining like terms, distribution, and even foiling binomials with I or complex numbers, as well as multiplying conjugate binomials together. And the real significance of this, besides just the general facts of it, ties into what we'll cover in the next video, in which we'll use basically the last concept of this in rationalizing denominators with I and with complex numbers. And I'll cover that in the next video. But for now, let's do the operations of the problems that I have on the board. The one that I have first would be an example of subtracting binomials of complex numbers. These are both complex numbers. This is real and imaginary, and this binomial has the real and imaginary part. Those quantities are both complex numbers. So all we're going to do is first distribute the negative through, and then we're just going to combine like terms. So let's just rewrite the first quantity, 1 plus 8i, and now distribute the negative through the second quantity to get negative 3 minus 9i. Negative 3 minus 9i. And now we're just going to combine like terms as if the I were an x. It's just that it's an I. So 1 and negative 3 are like terms. That makes negative 2. And 8i minus 9i equals negative I. And that's all there is to it. Just combine like terms and treat I like any variable. Now, one final thing you always want to check is that, do you have an I squared? If you do, you want to change that to negative 1. But in this case, we don't, so we can just leave that as I, as negative 2 minus I. So that's done. Let's look at the next one. The next one is distribution, multiplying an imaginary number through a complex number. So again, we're going to treat it just like a normal term with a variable. 5i times 1 is 5i. And 5i times negative 9i is going to become negative 45 I squared. Multiply the coefficients, 5 and negative 9, to get negative 45. And the i's, and since we have I times I, it's I squared. But as I was just mentioning, whenever you have I squared, you want to change that to negative 1. So let me rewrite this now as 5I minus 45 times negative 1. And once you get used to doing a number of these, you're going to notice that whenever you have I squared tacked on, it's going to become negative 1, which is then just going to change the sign of whatever number it's attached to. So rewriting the 5I, because that doesn't change, but then negative 45 times negative 1 now becomes positive 45. And now that one's done. Now let's look at the next one, which is now a binomial times a binomial, both of which are complex numbers. They both have I in it. And we're just going to FOIL it. Now we're going to FOIL it like normal, but again, we need to keep alert at the end where we may need to combine like terms and convert any powers, squared powers of I into negative 1. So we'll do that when we get to it. But first, let's just do normal FOILing. Product of the first is negative 6. Product of the outside is negative I. Product of the inside, 2I times negative 6 is going to be negative 12I. And 2I times negative I is going to become negative 2I squared. Now let's start back on the left and combine like terms. The negative 6 stays the same, and negative I and negative 12I is now going to become negative 13I. And now change the I squared into negative 1. And now we're going to bring everything down a line. So bring down negative 6 minus 13I. But now we're going to multiply negative 2 times negative 1, which is going to become positive 2. And since we changed the I squared into a number, notice that there's going to be one final step of combining like terms because we just created a new like term here of 2 with this negative 6. So now we can combine negative 6 with the just created 2 to get negative 4. And we just rewrite the negative 13I. And now we have our complex number, negative 4 minus 13I. And let's look at the last problem. And I chose these all in the succession that I did for a reason, because it basically walks us through the steps of most of what we need to know. Now, if we look at this binomial of complex numbers, take a look at that and see if you notice anything about them. Hopefully you notice that these are conjugate binomials or conjugate complex numbers at this point. So what does that mean? Well, we could FOIL them, but also we could skip a couple steps by doing the shortcut method for multiplying conjugate binomials. And that means all we really need to do is multiply the first terms. 3 times 3 would be 9. And multiply the last terms, 5I times negative 5I, which would be now negative 25I squared. Now you probably know where this is going. We have an I squared. Let's convert that into negative 1. Rewrite the 9 and the minus 25. And now interchange the I squared with negative 1. And now rewrite everything again, except now multiply the negative 25 times negative 1, which will now be positive 25. And now we can combine the 9 with the positive 25, and we get negative 34. Now we get positive 34. So now you can see how sort of what to expect from beginning to end of all these type of problems. We looked at adding and subtracting and combining like terms with I. We looked at distributing a term through a complex number. We looked at converting all instances of I squared into -1, which would then change the sign of the number it's attached to, and then, like we saw in the third problem, can then reveal another number that is alike with another number that can then be combined in the final step. And finally, if we look at multiplying conjugate complex numbers, we multiply them, and what we notice is we actually end with one number. So kind of the final take-home for multiplying a complex number times its conjugate is that when you follow all the proper steps and change I squared into -1, you're actually left with one number by the end. There's not even any terms with I. And that's all going to be valuable information for what we cover in the next video, which is rationalizing denominators with I. And I'll explain that in that video then, but just looking ahead, the key to rationalizing denominators with complex numbers is multiplying it, the top and bottom, by its conjugate, and that's the key to rationalizing denominators with complex numbers. So anyway, we're going to cover that next in the next video, and there's not much more to say here, so I'll see you in the next video.